Hello everyone, in this video we are trying to follow this book, Cloud-Based Remote Sensing with Google earthengine. This book is the massive resource to learn earthengine, to learn remote sensing, and also to develop some perspectives and thinking abilities in the domains of remote sensing. So this book has so many things, so many chapters for us to learn. And if you are not aware of this book, you can directly follow this book from this website, eefabook.org. And this is very easy to remember website. And my suggestions to anyone trying to learn is to be a grasshopper. And this is just an analogy. So this grasshopper eats 16 times its body weight every day. And this is what we should do to learn earthengine. This might not always be possible, but we can try for that. And in this particular video, I'm trying to go through this chapter F6.0, and this is titled as Advanced Topics, and really advanced chapter. And inside this chapter, inside this section, there is F6.0 as Advanced Raster Visualization. And I forgot to say one thing, that there's also the chapter walkthrough going on every week by the people who wrote this book. So you can see, find more information in this site. Anyway, we are trying to follow this chapter here. And this chapter has lots of things, of course. So the first thing to know about this chapter is that it says things about colors. It teaches us to add text and some things about animations. And my objective today in this video is to try to summarize. And so I'm sure lots of things will be missed, and because I won't be able to explain so many things, but this is an attempt. So also you can comment anything that will help me in my learnings. So we can also discuss the assignments, and please follow the chapter for more. So the basic idea starts here with the colors. So what types of colors to be used in what type of data depends not only on the choice, but also depends on the types of data. So they can be sequential or interval types of data, and there can be some negative and positive values, and there is something called a circular. Some value might repeat at the same time, and semantic, in which we give the colors according to the context. For example, in the case of ice, the ice will have the white color. So there are different color maps from different packages, and these are the basic things that we need to know. We need to know about colors. So there are already lots of packages for that, and some examples has been given. So for example, Viridis from Matplotlib, Turco from Kremen, and others. So these types of colors are used for visualization, and most of the times while choosing these colors, this is made sure that everyone can see those colors. And we have the very first sets of codes here. So there is also the repo, and from this repo I have copied each one of the checkpoints or the sections, and try to copy and try to reload this. So here is the very first one from this chapter, and so let's go through this. So here we have this image collection, image collection, and here is some data set, and this data set contains some things with the climate, and inside which we have this temperature underscore 2 meter, and we're selecting that from this ERA5 variable. And before that, we can see this palettes variable, inside which we have loaded the packages palettes. So in general, this whole chapter is about the packages, that contains the colors and things are text, and trying to use that is what this chapter does. So here, anyway, here is this package. This is something similar to this library in R programming language, if you are aware of that. So we are just loading the this package in this variable, and then we are here choosing a diverse color map for anomalies. And so this this color map balance is from this CM Ocean package, and this is provided, or this is assigned to this balance palette. So here we are selecting .cm ocean and .balance. So this is the color map balance from the CM ocean package. So so we are selecting the color map balance in this way. For now, I'm not sure what this 7 is. It might be related with this particular color map. And then we have this next variable, 3 color palette, inside which we have the list, blue, white, and red. So 3 different colors. And here I have already run this, and you can see something in the console. So this has been done by palettes dot show palette. So here is this function, and here we are giving this text, and then here we have the variable. So this whole line is giving this one here, the first one, and the second one is giving this one here. So this is just showing what types of colors or what types of colors are inside these 2 variables. And then from that above data set, we are filtering the date. Here previously we selected the temperature underscore 2 meter. That was the temperature neogram we had selected, and here we are filtering the date from the 1981 to 1991, and then after we have this 2011 to 2020. So filtering it by the somewhat 10 years period, and this has been followed by .min. So it gives the min image, the final image. That the final image will be the single one, and this has been repeated to the next one as well. So 2 different min images from the 2 different time periods. And here we can see this being subtracted, ERA 1980 being subtracted from ERA 5 underscore 2010, and this gives the difference image. And so as told before, the whole idea of the chapter is the visualization. So here we are providing different palettes. So map.add layer, this is the function to add the image as the layer, and here inside the palette only this is the difference. So the first one uses the 3 color palette, and the second one uses this balance palette, and what we get is this one. So this is the blue, white, red palette, and this is the balance palette. And so what the book suggests is that the balance color map has this more elegant and professional feel to it, because it uses a perceptual uniform palette and both saturation and value. So this is the way the book shares us the idea, and I think this is true because this color, this balance palette, looks not that bright, and it really seems kind of professional. So this is the first section. So here we loaded the data set, also loaded the package, and selected the temperature_thermometer, selected this color map balance from the CM Ocean package. So next time we will remember this one if we might need to do with the temperature data set, and then after we have this palettes being shown in the console, then we have this two mini images from the period of 10 years. We subtracted the two images, and then we added it as layer with two different color palettes, and the book suggests that this balanced color map is more elegant and more gives us the more professional tone. So this is the first subsection. And the second section, or the second set of codes, here we can see this is the semantic color map, and by semantic we are assigning the color to the object or to the image based on the object's knowledge or idea. Maybe just the way to say that if the ice is to be given the color, then it will be given as white. So there's the general concept. So here we have this image ID, and from that image ID we select this HH band, and here we are again loading this package or the library, and from this here we have this ice color map from the CM Ocean package. So now we know that the package CM Ocean contains different color maps. Previously we saw the other one, and here we are seeing the ice color map. And then here we can remember this, that palettes.showPalette gives us something at the console. So this shows us with the color, and then we can add this as the layer. And here we're for color we're selecting this ice palette and some minimum and maximum value, and then we can see this one, the image is now in the map section, and the last one here zooms to that point with the zoom level 8. So in this code, or in this sections of codes, we are just using the this ice color map to visualize the assets, and everything is being done by itself. Means to say that minimum and maximum values has been automatically assigned with different colors. So this is the second sets of codes. Then we move to the third one, and this particular course section deals with the line cover data, and here the code assign the line cover bands with different color. So let's see. So here we have this NLCD. So this is the land cover data set, and then we are filtering it with the year 2016, and we're selecting the first. So just to select the 2016 dataset, and from that we're selecting the land cover, and then we are adding this as the layer. So the first one is the NLCD land cover. So we get this one. This is the NLCD land cover. So now we try to change the color palette. Means we are providing different colors to the different classes. So the different hexadecimal values of different colors has been created as the list. And now we are adding this as the new color palette by map.add layer. We have our variable name and we have our colors. And this is the NLCD new palette. And we see this reddish color. And we are getting the land cover class values from that land cover data set. We are printing the values here. We can see different values starting from 0 to 19. So we determine the maximum index value just to know, just subtracting the first one. So if there is 19, actually there is 20, so we are just determining the maximum index value here, and again creating a new index for the remap, 0 to maximum index, and we print the updated class values to console. And now we are assigning the remapping the NLCD values and displaying it in the map. So what is happening is when we assigned this these colors, it didn't really work. So for this we had to remap the values and indices with the new colors. So this is the process that's being done. So so why is this happening is the book shares us the answer. So the numeric codes for the different classes are not sequential. So new index for the class value was needed so that they are sequential. So that's the thing. So first, in the raw class values, so we have 0 starting as 11, 1 starting as 12, 2 starting as 21, 3 starting as 22, and there were some, the numbers or the classes were just arranged in different ways. But after updating the class values, we see that this has been in a very nicely fashion from starting from 0 to 19. So just the in this code, just we learn to remap the class values with the updated class values. So what really happened was this first one was the original one. We tried to add the colors, but it wasn't working, as we saw that the class values were not arranged in a nicely order. So we remapped here as the values with the new indices. So here is the dot remap. So this will also be important when we do the clustering or some kind of unsupervised classification, in that we might need to assign the different classes in the single class. So in that purpose, this will be very important. And so the final one is the remapped color. So that is the thing. So this is the third sets of codes. Then we have the fourth one. So the fourth one is all about adding the text. It's very nice. So I have already run this, and what it shows is the texture hello world in the map section. So again, this whole chapter is about learning how to use this package. So here is the gena package again, and here we have this packages colon text. So this package is related to the text. So we have map.setCenter. So this 0, 0 is the specific coordinates, 0, 0, and the zoom level is 10. So this map.setOptions is set as hybrid, and I found that this hybrid just now, I didn't know that one, and this hybrid option is in the dark background, so this will help the white color text to be visible. So that is why this example is given, but we also get a chance to be aware about this hybrid, map.setOptions hybrid. And then after we have this map.getCenter. So this has been assigned in the variable pt. So this gives us the center of the map console, sorry, map section. And then after we are also we can also see this variable scale by map.getScale. And here we have this image variable, and here we see the main thing being done. So this is the text, the package, and we have this .draw. So we are using that package and asking that package to draw by .draw, and then we have this string, and then we have this map.getCenter, that is the pt. So this gives us the position, and then we have this scale, some values for that text to appear, and this is now set as the image, and we are adding this as the image. So that text needs to be converted as the image. So this is the whole idea of doing the text in the earthengine. We have to draw the text as the image, and then for that string to appear, we also need to provide some points or the location and some scale values. And finally we add this as the layer, and we get this hello world in the map layer. So this is the fourth sets of codes, and then we move to the fifth one. So let us run this again. So this begins with the same thing. So this is the package here, packages colon text. We have map.center, the very center of the map, and again options as hybrid, and we saw this before. So now this set of codes adds something more, and here it changes some font style and how it appears. So here we have the font size, font type, the text color and the outline color, then the outline width and outline opacity. So we have different other parameters that can be used to make the text appear something very different. And again, this has been added as the layer. So we get the text also as the layer in the earthengine. So we have some other parameters to know here, just the font size, font type, where to appear, text color, text opacity, text width, outline color, outline opacity, and outline width. So this will be This will be helpful if we want to add the text in the image. So this is the lesson from these sets of codes. Then we have something more advanced in this one. So the basic idea is to add the text, but here this does something very differently. So the idea here is to make the values or the percent of clouds appear in this or in this Landsat image. So it seems very nice. So let's see what has been in the code. So the first one here is again loading this package, and here we have this geometry as polygon. We are adding we are centering this as the object with the zoom level 6. So we are adding this as the zoom level 6, and we have this function annotate image. So what it does is it annotates an image by adding outline, border, and cloudiness, and the cloudiness is shown as a text string rendered at the image center. So this will add the edge to the image. So this is being done by ee.feature collection, image as the parameter. Then we have this dot style, some color and fill color, and the cloudiness will be drawn as text. The text color is provided, the outline color, outline white, outline opacity, font size, and font type. So these are some parameters for the text, and then we are centering that image. So this this image.geometry gives the boundary of the image, and there is dot centered here, and after that we have this variable string. So from that image we are getting the cloud cover by image.get cloud cover, and this will be formatted in some values. So this is just the this dot format makes the text makes the number just rounding off and showing some with some digits, and finally this will be as the number, and we have this map.get scale. So this gives the scale of the image, and then we are drawing the text. So we have this text, the package, then dot draw. So this is the string. So this will appear in the center, and this will have some scale, and then we have this PROPS. This is just the parameters for the text to appear, and it says the shifting of the left 25 pixels. So I'm not sure for this for now, but this has provided some values such as the this one here, coordinate reference, and finally we are returning this as the image collection. And here we are selecting the image, selecting some bands, filtering with the geometry, and filtering with the depth. And then we can see that something is being added as the layer. So this is the ee.image one. So this is the constant image. The color will be black, and this will be shown every time we load it. And this is what we get, the very black shaded area. Not exactly black, but still transparent enough. And then we have this images added as the layer with minimum and maximum values. some gamma has been provided, and this is now as images. And from where those images came is this one here. So this has been added as a layer. Now in those images we are adding the text by the function that we just created before, by dot map and annotate. And then we have this UI dot map dot layer, labels, and then annotations, and adding them as the layer. So this is the final one that we see now with the text. And so this needs to be rendered. So now we can see the text appears, so the numbers appear something very bold, not inside the image. So this has been corrected by re-rendering with the zoom images, while the zoom changes. So the scale depends on the zoom. So here is this map dot on change zoom. So this will help to make those numbers appear inside the image. So this is something here. So anyway, this is the very nice nice sets of course, doing something very wonderful, making the text or making the numbers appear in the image. Very nice one. And then we have this next sets of codes, so you can run this. And so here again we have this package, palettes and text being loaded. We have the point, and we have this polygon, and then we are again looking this ice palette, and then we are showing it in the console, and then we are centering some object, this point, with the zoom level 9, and then we have the Sentinel images, selecting the assets, filtering it by the dates and filtering it by the area, and then we are including one of the images which fully contains this region geometry. So any images should contain this one, this geometry. So here we can see the filter, and so there's a lot of things in the joints. So this is just the left field and right field, how the joint works, and we can print the images by dot size. So what is going on this code is that it's not actually showing. So for now this has not been, there's nothing in the so what is it is just showing the size of the images. I'm not sure why it is not doing anything. I think the objective here is just to show the size of the image. Anyway, this is the sets of codes, and then we can move to the next one. Please check this more here. Then we have the next one here. So this is the oh, I remember, this is just the continuation of the this is just for the continuation for the next sets of codes. I'm very sorry for that one, not understanding it well. So this one continues in the next one. So in the book there is the checkpoints in the every sets of codes. So the next sets of codes begin with the previous sets of codes. So that is what is happening here. So again we have this palette and text, we have the point, and then we have this geometry, and then we have this ice palette. We saw the ice palette in the console, centering, the point with zoom level 9, filtering the images, and the images should contain this geometry, and we are printing the size of the image by dot size. So this is a very important function here. So this was the previous sets of codes, and we continued from that one, and now we are adding the something in the image. So we have this palette minimum and maximum value. So this is the visualization. We get the scale, and then we have this text properties, outline color, outline white, outline opacity. So this will be the text properties. So now here we have the function, the very important one. So what we are doing with the images is that in those images we map the function. We have this I as parameter, and from that I we take the dates, format it as the year and month and date, and we label the image. So our date is now the text to be appear in the image. So we have this text dot draw. Text is the package, and this label is the date, and the point is something where that will appear. We will have the scale and some text properties, and then we are returning it by image with some visualization parameter, and this dot blend will label the image on the top. So we are adding these text or the date at the very top, and we have this dot set with some levels. So it keeps the text property, and this has been added as the layer. So this one is the layer. So the first one is the layer here. So only the text, so we can see this one appear here. This is the date, and then we have the polygon here. So this is what it is doing, making the date appear at some points here. So now we continue again. So again, this is the palette here, our text package, the point, and then we have the geometry polygon, and then we have this ice map, ice palette, and then this appears on the console, centering it as object, selecting the center one images, filtering it by bounds, filtering it by the dates, and selecting the attach, and we want to make sure that images contains that geometry, so we can print the number of images that we see earlier. And then we have the visualization, getting the scale, text properties, and adding that date in that image. So now the objective is to animate. As you can see, I have already run this and something appears in the console. So this is the animation, and here we have this GIF parameters. So the region has been selected, the rectangle, dimensions, CRS, frames per second. So this will be the parameters for the GIF visualization, and this images RGB with dot get video thumb URL with GIF parameters shows the animation in the console. So the images RGB is this one. So we had mapped the function to all those images by adding the date to be appeared at the very top. And this is the way to make the GIF URL appear at the console by dot get video thumb URL. And this, oh, I'm sorry, this dot get video thumb URL is showing us this this link, and UI.thumbnail gives us this animation in the console. So this link will give this animation, and this can be exported as the video or the animation. or as the clip to the Google Drive. So this is done by export.video.to-drive. So the collection is images RGB, description and file names, prefix, frame per second or other things has been provided with this one. And then there is something new. So this package, this animation package contains some way to provide a way to get the get this one here, this box here, which contains some kind of scrolling, and we can play this. So this animate function in the package generates an interactive animation. So that is the thing. This is done by animation.animate, and it provides us with this interactive toolbar in the map section. And this is the very nice thing to do or to learn here. And then we have this next one. So this is the second last one, and this is related with the visualization, and this shows the way how this DEM appears in the map layer. So the first one here is this DEM loading, being loaded as the variable DEM. We have the map set options as hybrid, and this map.setCenter with zoom level 18, and then we have this palette, black and white, 2 different colors as the list, and then we have this DEM that visualize with minimum and maximum values, and with the palette, and we add this as the layer. So the first one here is the DEM. So you can see the first one here is the DEM. So this is the DEM with black and white color, minimum and maximum values, and then with the color palettes, black and white, and this is being added as the layer. And then we have this package, UTILS package. From that, for that package, we have this different parameters. We have the weight, exaggeration, azimuth, zenith, brightness and contrast, saturation, cast shadows, and then we have this RGB variable, inside which we have this dot hill set RGB, and we have done all those parameters inside this parenthesis and added it as the layer. So now this is the DEM with no shadows. Now this is now the next one. Now this says that cast shadows is true, and now this provides some colors and says DEM with shadows. And then we have these palettes again being loaded, and some color map here, and again visualizing with minimum and maximum values, with palettes as this one here, and again cast shadows as true, and now we get something like this one, the very colorful and very wonderful image. So this sets of codes is related with the DEM and making the shadow appear in the DEM layer or the DEM image. And we can also see that even in the DEM some colors can be generated, and it provides some realistic view to the DEM. And finally, this is the last sets of codes. So it is not exactly explained in the book. It is just making or just being shared for the readers to explore themselves. So if we run this, what it does, it does something like this. So the images appear in something like this in a row and column fashion from January to December. And let's see, so we have this, let's see what's in the code. So we have this geometry level, I point, and this geometry polygon as the polygon. So two different things, point and polygon. Then again, the library has been loaded, text and gallery. We're centering the object as the we're centering this object here with the zoom level 12. Then we have the images, central to images, being filtered with some dates and bounding it with by this this point. And then we have this images monthly. So from 0 to 11, or from first month to the last month. And in that sequence of numbers, we're mapping the function. So this will be the month here. So the first month is being selected here. And then we're routing the images with month to month. And so this will be the monthly image, inside which we have these three different bands, band 12, 8, and 4. And reducing it with by some percentile and some level is there. So we have this ee.date dot from YMD, and after that this adds the next month and format this as the some month here. So in general, this is doing a monthly image, selecting the three different bands, reducing it with some percentiles, and also adding some date properties to the image. So this gives the monthly image, and this whole images is now being done as the image collection. So e.image collection makes those monthly images as the image collection. So then it says rendering the monthly images and level, so it adds something here. So we have this image collection, and then we are mapping this function with I here, and from that image we are getting the level. So here we had made this before, so this will be the string that will be drawn in the image. So text.draw will make those text appear, and this geometry level again is the point in which those text will appear, and some scale here and other text parameters here. And this will return the image with minimum and maximum values from here, and adding this text. So .blend level, .blend will add the text to the image. Then after we have this rows, columns, and then we have this gallery. So this gallery is this package. So this will draw images, all images will be drawn, and this geometry gallery is the polygon of which this boundaries will be taken, and the rows, it will be arranged as the rows and columns, and this has been added as the layer. So again, so many things are going on. So first monthly images were taken. From those monthly images, in those monthly images some levels were also being created, and those levels were the month. So this was being added to each image, and this has been shown as the images in this fashion, from rows to columns. So this is the overall of the overall picture of the chapter. So please go through the book, please go through the chapter, and if you have any comments, or not really, if you have any thing to ask, please write in the comment. I'll try to read them, and I'll also try to learn more. So I hope this was helpful. If you have followed till the end, I'm not sure. So if this was helpful, please you can give a like or say hi to me. So this much in this video, but I'll try to follow other chapters as well. So let's be a grasshopper and try to learn more. So this much in this video. Thank you for watching.